Welcome to the lecture on solving quadratic equations. We're going to learn 4 methods for how to solve a quadratic equation, and the first 2 methods only work for particular quadratic equations that you're given. The other 2 methods will work for any quadratic equation that you're given. So the first technique is one you've already learned, and it's solving a quadratic by factoring. So let's review with a couple of examples. In the first problem here, we have 2x squared plus x equals to 3. So in order to solve this, when you're trying to factor, you always want to get a 0 first on one side of your equation. So in this case, I can do that by subtracting 3 to the left side, so that I have a 0 on the right-hand side. And now we're ready to try and factor. Because this is a trinomial, we'd want 2 sets of parentheses. And in the first position, we're looking for 2 things that multiply to 2x squared. Well, that's got to be 2x and x. And in the other 2 positions, we want 2 numbers that multiply to negative 3. Well, we could put 3 and 1, or we could do 1 and 3. In order to decide which case it is, we need to make sure that we're getting a middle term of positive 1. So in order for that to happen, we need to separate the 2 and the 3. So I'm going to put the 3 here and the 1 here. That way my middle terms will be 2x and 3x, and in order to get a positive 1, I'm going to need to make the 3 plus and the 2 minus. So that's how we're going to want to factor this. So once we have it factored, then what we're going to do is set each factor equal to 0, and this is called the zero product property. So we're going to set 2x plus 3 equal to 0, and we're going to set x minus 1 equal to 0, and we're just going to solve each of these. So we get 2x equals negative 3, so one solution is negative 3 halves, and in the other case we get x is 1. So my 2 solutions are negative 3 halves and 1. Okay? If we try another example, we have 3x squared plus 10x minus 8 equals to 0. We already have the 0, it's already as simplified as it can get. So we're ready to try and factor, and this is a trinomial, so again we want those 2 sets of parentheses. In the first 2 positions we want 2 things that multiply to 3x squared. The only way to get that would be 3x times x. In the second position we want 2 things that will multiply to 8 and at the same time give me a middle term of 10. So since this leading coefficient is not a 1, there's going to be a couple choices that we might need to consider here. So let's consider how to get 8. We could do that with a 2 times 4, or in the opposite order, 4 times 2, or we could do 1 times 8, or 8 times 1. So those are all of our choices. Now to decide which one it is, we need to check those outer and inner terms. So 3 times 4 would give me 12x, and 2 times x would give me 2x, and those 2 have a difference of 10. If I make the 12 plus and the 2 minus, then I will get a positive 10x. So this is the solution that we're looking for. We got lucky and got it on the first try. We want a minus in front of that 2 and a plus in front of that 4. So let's kind of clean up our answer here a little bit. So our final solution looks like 3x minus 2 times x plus 4. Setting each of those to 0, we get 3x minus 2 equals 0. Add 2 to the other side, divide by 3. So one solution is 2/3. For the other factor, if we set it to 0, we'll get negative 4. So our 2 solutions are negative 4 and positive 2/3. So that's solving quadratics by factoring. Unfortunately, that solution or that method will only work if you have a quadratic that's factorable, and unfortunately not everyone is. So we're going to have to learn some other techniques for how to deal with quadratics that aren't factorable. Now one other special way to solve quadratics is called the square root property, and this is a special property or theorem that you can use whenever you have a quadratic of a particular form. The form that you need to have is x squared equals to b. So in this case, notice that we have the x squared term, and it's isolated on one side, and we have a constant on the other side. So this isn't going to work if you see any x terms in your quadratic, because this has no linear term in it, only the x squared term and the constant term. So this is why it's a special case. It only works in particular cases. If you have something of this form, then all we have to do is take the square root of both sides, and we're going to get the solution to be x equals plus or minus the square root of b. So for example, if I have x squared equals to 7, then I can just take the square root right away to undo that square. The square root and the square cancel each other out. And technically we don't just get x, we actually are getting absolute value of x equals to the square root of 7. But if you recall when we talked about how to solve absolute values, there's two solutions to that. Either x could be the positive square root of 7 or x could be negative square root of 7. And that's why we get two solutions. X equals plus or minus square root of 7. Usually we skip the step of writing the absolute value and we just jump directly to the plus or minus case. So here my solutions would be plus or minus square root of 7. Okay, another example of that, if I have x squared equals to negative 4 and I take a square root right away, we're going to get x on the left side, but as soon as I just write x instead of absolute value of x, you need to remember to put that plus or minus symbol on the right hand side. Now we wouldn't want to leave this as square root of negative 4 because that can be reduced. We've got square root of 4 and we've got square root of negative 1. If we break it down, the square root of 4 turns into a 2 and the square root of negative 1 is I. So at this point you've learned about complex numbers, so you are allowed to give i's in your answer. We are allowed to take the square root of negative numbers in this particular section. So plus or minus 2i would be our solutions. Okay? In another example, these also are going to be done by the square root property. They don't look quite as simple as the last two examples because you have a whole quantity squared, but if you want to undo that square, you can use that square root and take the square root of both sides to keep it balanced. The square and the square root will cancel out, giving you that x plus 4 and a plus or minus square root of 5. Then to finish solving this, all we have to do is finish isolating x. So if I subtract 4, you can do that a couple of ways. I usually like to put that minus 4 in front of my plus or minus symbol, but it would also be correct to write plus or minus square root of 5 minus 4 and putting the minus 4 off to the right. I like to write it this way just because I think it looks a little bit cleaner. But both ways is correct. So here my solutions are negative 4 plus or minus square root of 5. Remember that if you have negative 4 plus square root of 5 and negative 4 minus square root of 5, you can write them separately if you like, and those are called conjugates. They are exactly the same expression, but that middle sign in between is opposite. Okay? So whenever you get irrational answers like we did with that square root of 5 in there, they always come in conjugate pairs. Just like our I answers over here. Whenever you have an I as part of your solution to a quadratic, they will always come in conjugate pairs. So you'll have the plus and the minus case. So here's our solution. Alright, let's try one more example. Once you get that whole quantity squared isolated so that there's no numbers in front or off to the side, then you're ready to undo that square root right away. The square root and the square cancel out, giving you 3x plus 1, but you automatically get a plus or minus on the right hand side, and here we get square root of negative 6. Now the square root of 6 does not reduce, but the negative under the radical does become an I. So this is like square root of negative 1 times square root of 6, which is an I square root of 6. I usually like to put the I in between my plus or minus symbol and then the radical, just so that it doesn't get confused as being put underneath the radical. So I usually put my i's in front, but it really doesn't matter as long as you're careful how you write it. Now we need to finish solving this for x, so the next thing I'd want to do is move this plus 1 to the other side by subtracting, and I'm going to put that in front of my plus or minus symbol, so negative 1 plus or minus I square root of 6. And then to finish solving for x, we'd want to divide by 3. There's two ways you can do this. You can divide the entire fraction by 3, so your answer would look like -1 plus or minus I square root of 6 all over 3, and that's perfectly correct. The other option, instead of dividing the entire fraction by 3, just divide each individual term by 3, which is also correct. So x could be -1/3 plus or minus I square root of 6 all over 3. So either way you write it as one single fraction or two separate fractions is correct. Okay, so far we've learned two techniques for solving quadratics. Factoring, which only works if you're given a factorable quadratic, and the second case is this square root property, which only works if you have the form quantity squared equals to a number. So in the next example, next method we're going to use, called completing the square, this is more general. It lets you solve any kind of quadratic that you want. So this is a little bit more powerful than the other two methods. Unfortunately, it's a little bit trickier and a little bit harder to follow sometimes. It's a little more work. So let's start with our first example here. We have x squared minus 2x equals to 1. Now normally we would want to get that 1 over to the left side, set this to 0, and see if this would factor. Unfortunately here, if you subtract that 1 over to the left side, there's no way to factor this because of the signs. If I have a -1 on the end, there's no way I'm going to get a middle term of a -2. If this had been a +1, then I would have been able to factor this. So unfortunately, because of my signs, this doesn't work. So actually, instead of bringing that 1 over, when we complete the square, we usually like to bring that constant over to the right side and keep it away from the two x terms. So I'm going to write this as x squared minus 2x. Then I'm going to leave a little space right here and then have my equals to 1. And the reason I'm leaving this space is because we are going to have to add in kind of a special constant so that we can try and factor this left-hand side. That's what completing the square means. Adding in the appropriate constant, so on the left-hand side we'll get a nice perfect square which will factor, and if we can get it written as a quantity squared, then we'll be able to use that square root property that we just talked about. So in order to make this factor, the first thing you need to make sure of is that this leading coefficient in front of the x squared term has to be a 1. And in this case it is, so we don't have to worry about it. But in a couple of later problems it won't be a 1. And if it's not a 1, all you have to do is divide each term through by that leading coefficient so that it turns into a 1. So you always want that leading coefficient to be a 1. Once it is, then what we're always going to do to get the right terms so that this can be factorable is we're always going to take 1/2 of this middle coefficient. So in this case that middle coefficient is -2. Half of -2 is -1. So in our quantity squared, we are going to want x minus that 1 quantity squared. What we would like is for this whole quantity to be equivalent to the left-hand side of this equation. Right now it's not. If you were to FOIL this out, you would get x squared. You would get a middle term of -2x, but you would also get a +1 on the side. And there's no extra +1 over here on the right-hand side. So what we need to do is add in that missing constant. And the missing constant is always going to be the answer that you got from taking 1/2 of your middle coefficient and then squaring it. So if I square that -1, it becomes a +1. Now if I add it to the left side, we also have to add it to the right side to keep the equation balanced. Otherwise our final answer won't be equivalent to what the original solution was supposed to be. So whatever I do to the left, I also have to do to the right. Now by adding in that 1, these three terms now do factor into this quantity x minus 1 squared. If you were to FOIL this out, you would get these three terms. So that's called completing the square. Taking half of your middle coefficient, squaring that, and adding that constant to both sides so that now the left side will factor completely. Okay, so now we have the left side in a factored form with these parentheses, but on the right side we're going to get a new constant. Instead of having that 1, now we get 1 plus 1, which is 2. Once we get it into this form, in this factored form, we can now use that square root property that we just talked about. Because if we take the square root of both sides, the square root and the square will cancel out. We'll get x minus 1 on the left side. We'll get plus or minus square root of 2 on the right side. And now it's really easy to solve for x. We just have to add 1 to the right-hand side. I'm going to put that 1 in front of my plus or minus symbol. So my two solutions are 1 plus or minus square root of 2. So this whole process is called completing the square. Taking half of that middle coefficient, that's what's going to go inside of your parentheses, squaring that number and adding that square to both sides so that now the left side will factor, and then you finish it off by taking the square root. Okay, so it's kind of a complicated process. Let's try another example. So in the next one here, the first thing we want to do is make sure the constant is on the right-hand side, and right now it is. We would also want to make sure that this leading coefficient is a 1, and here the leading coefficient of p squared is a 1. So we're ready to go. I'm going to rewrite my p squared minus 8/3 p, the two terms with p's in it, leave a little room, then write my equal sign, and then that negative 1. Now that I have it all spaced out, we're ready to take half, you always take half of that middle coefficient. So half of negative 8/3 in this case. Now half of negative 8/3, you can reduce that a little bit. 2 goes into 8 4 times, so this is minus 4/3. Now that number is the number that's going to go in your quantity squared. So it's going to be p minus 4/3 quantity squared. However, this is not equivalent to our factored form yet because in the original problem we're missing the constant that you would get if you were to FOIL all this out. So what constant is it that we're missing? It's that same negative 4/3 squared. So I'm going to add that to both sides. Negative 4/3 squared becomes positive 16/9, and you're always going to be adding that to both sides, always addition. So now these three terms do factor correctly into this quantity squared. So I've done it correctly, but on the right hand side now we're going to get a new constant. Instead of negative 1 we're going to get something else. Now in order to figure out what that constant is, you can use a calculator here. I'm just going to do it with a common denominator. Negative 1 is the same as negative 9/9. So when I add that to 16/9, negative 9 plus 16 gives me 7/9. Now that I have it in this form, where we have that quadratic kind of in this factored form, we're ready to do that square root property. So I'm going to take the square root of both sides. So on the left side we get p minus 4/3, we lose the square. On the right side we're going to get that plus or minus symbol, and think about square root of 7/9. This is like square root of 7 over square root of 9, and square root of 9 is a perfect square. So this becomes square root of 7 on top and a 3 on the bottom. Then to finish it off, we're just going to add 4/3 in the front, so p equals 4/3 plus or minus square root of 7 all over 3. And there are my two solutions. Okay? Alright, let's try two more examples, and these last two here do have leading coefficients that are not 1s. So we will need to divide through by that leading coefficient first before we do anything else. So if you want to move the constant over to the right-hand side first, that's fine. But at some point you want to make sure that you do divide through by this 2. And you want to make sure you divide all three terms by 2. So this is going to be x squared minus 5 halves x. I'm going to leave a little space, and then on the right-hand side we're going to get negative 2. Now that this leading coefficient is a 1 and we have everything spaced out correctly, we can go ahead and take 1/2, it's always 1/2, of the middle coefficient. In this case, since we have fractions and nothing on the top cancels with anything on the bottom, we're just going to multiply top times top over bottom times bottom, so this is going to be negative 5/4. Now that is the number that goes in your parentheses, so this is going to be x minus 5/4 quantity squared. But we need to add in our missing constant to make this really true. So the constant we need to add in is that same negative 5/4 squared. So if I square negative 5/4, it becomes positive 25/16, and I also need to add that to the right-hand side. So now these three terms factor into the quantity x minus 5/4 squared, but we're going to get a new term on the right-hand side, and again I'm going to need a common denominator of 16. So the second fraction is fine, but negative 2 is the same as negative 32/16, since 16 times 2 is 32. Negative 32 plus 25 is negative 7/16. So now we have it in our nice form for that square root property. So let's take our square root of both sides. On the left side we get x minus 5/4. On the right side, remember that plus or minus symbol. We have a negative underneath our radical. Remember, a square root of a negative becomes an I. Square root of 7 on top doesn't reduce, but square root of 16 does reduce into a 4. So the denominator, you want to reduce it to 4. So we get plus or minus I square root of 7/4. The last thing I'm going to do is add 5/4 in front. So I get 5/4 plus or minus I square root of 7/4. So my solution, 5/4 plus or minus I square root of 7/4. Okay? Let's try one last example with completing the square. First thing I'm going to do here is take that minus 2 and I'm going to add it over to the right-hand side, leaving some space here. And this leading coefficient is not a 1, so we need to divide every single term by 3. Unfortunately, nothing really divides unevenly, so we're going to be left with some fractions. X squared minus 5/3 x equals 2/3. We have the leading coefficient 1. We have it all spaced out. So now we're ready to take 1/2 of that middle coefficient. So 1/2 of negative 5/3. Nothing on the top cancels with anything in the bottom, so top times top over bottom times bottom is going to give me negative 5/6. That number is what goes inside of your parentheses, quantity squared. So it's going to be x minus 5/6 quantity squared. To make this correct, we need to square that same number and add that to both sides. So negative 5/6 squared becomes positive 25/36, and you're always adding that to both sides. So there's my new constants added on. The left-hand side is now accurate. If I were to FOIL out this quantity squared, I would get exactly what we have up here, these three terms. So the left-hand side is now equivalent. But on the right-hand side, we need to figure out what this new number is here. So common denominator again, this time 36. 3 times 12 is 36, so 2 times 12 makes this numerator 24. 24 plus 25 is 49/36. So we have it in the right form to use our square root property. So we're going to take the square root of both sides. The left side gives me x minus 5/6 equals plus or minus. And notice here that the square root of 49 over the square root of 36, both of those reduced. Both of those numbers are perfect squares. So the square root of 49 is 7, square root of 36 is 6, So this just becomes 7 6. We have no radicals left over. Now, because we don't have any radicals left over, that means we're going to be able to simplify here. So when I go and I add this 5 6 out front, and I get x equals 5 6 plus or minus 7 6, you wouldn't want to leave your answer like that because there's no radicals, so these are actually going to be like terms that we can add. And you want to do both cases separately. So if we do the plus case, then it would be 5 6 plus 7 6, which is 12 6, and that reduces to 2. So one of our answers is 2. In the minus case, we would have 5 6 minus 7 6. 5 minus 7 is negative 2 6, and that reduces to negative 1/3. So our two solutions are negative 1/3, comma 2. Now the fact that I got nice rational answers with no i's or no radicals left over means that this original quadratic that we had was factorable. And if you do a little trial and error here, you'll see that this quadratic actually factors into 3x plus 1 times x minus 2. That gives us the 3x squared, the minus 2 on the end, and the middle term, we get a plus 1 and a minus 6, which gives us that minus 5. And if you were to set each of these to 0, you're going to get that negative 1/3 that we got, and you're also going to get that positive 2 that we got. We didn't even check to see if this factors. We probably should have, otherwise it would have saved us a lot of work. Instead of having to do all this completing the square, we could have just factored and gotten our two solutions very quickly. So that's one thing you do want to check for. If it looks like it's something that might factor, then try it, because you might save yourself a lot of time and avoid using completing the square altogether. Okay? So we've got factoring, we've got the square root property, we've got completing the square. Our last method for solving quadratics is something called the quadratic formula. And what the quadratic formula says is that if you have any quadratic set equal to 0, it must be set equal to 0, and it's of the form ax squared plus bx plus c, then your solutions for x are going to be given by this formula. Minus the b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So the a, the b, and the c are the coefficients of your three terms. So let's try one of these out and you'll see how it works. When you're first given your quadratic equation, you have to set it equal to 0 before you use the quadratic formula so you can identify what your coefficients a, b, and c should be. So in this problem, I'm going to need to subtract 2x over, and I want to put this in descending order. So that means put the squared term first, then the linear term, then the constant, set it equal to 0. So if we put it in this form, then the leading coefficient, which in this problem is 1, that's your a. The middle coefficient, which is negative 2, that's your b, and the constant on the end, that's your c. So c is negative 4. So now we're ready to apply our formula. X equals minus b. So if b is negative 2, we want the opposite of that, so it turns into a positive 2. Plus or minus the square root of b squared. Notice that I'm wrapping that in parentheses because we want to square not only the 2 but also the negative. Minus 4 times a is 1, times c was negative 4. Again, I'm using parentheses here so that I can make sure I'm using all my signs correctly. So there's my b squared minus 4ac, and then this is all over 2 times a, so 2 times 1. So that's this formula with everything plugged in. Now we just need to simplify it. So if we start with that denominator, 2 times 1 is just 2, and now if we go to that square root, negative 2 quantity squared turns into a positive 4 because we're squaring the negative, which makes it go away. And then a minus 4 times 1 times a minus 4, Two negatives make this positive, and 4 times 4 is 16. So under that radical, we get 20. 4 plus 16 is 20. Now when you're giving your final answers, please remember that you must simplify the radical. Square root of 20 is not reduced because it's divisible by a perfect square. Square root of 20 is 4 times 5 under radicals, and square root of 4 turns into a 2. So you have to always simplify your square roots. So this becomes 2 plus or minus 2 square root of 5 over 2. The other thing that you need to always simplify is your final fraction. If you look at all of your outside numbers, not the number under the radical, but all the outside ones, if they are all divisible by some common factor, then you need to divide through by that common factor. And all of these 2's are divisible by 2. So if I divide through by 2, 2 divided by 2 goes to 1. 2 root 5 divided by 2 goes to just root 5. And in the denominator, 2 divided by 2 goes to 1. And we don't even need to write that 1 in the denominator. So my solutions are 1 plus or minus the square root of 5. So your instructor will always expect you to reduce your radicals and reduce your final fraction. Okay, so that's the quadratic formula. Let's try another example. Here we have 9x squared minus 6x equals negative 7. So in order to solve this, we first have to add that 7 over to the left-hand side because we want to get a 0. The a is the 9, b is the negative 6, and c is the 7. So according to our quadratic formula again, we want minus b. So the opposite of b turns this to positive 6, plus or minus the square root of b squared. So for now I'm just going to write that as negative 6 quantity squared, minus 4 times a, which is 9, times c, which is 7, all over 2 times a, 2 times 9. So don't try to do all of this in your head at once. Just fill in all the blanks with the numbers you're supposed to be substituting in wrapped in parentheses. Then in the next step you can worry about trying to simplify. So let's do the denominator first. 2 times 9 is 18. Under the radical, negative 6 squared becomes 36. And then for my other terms here, I'm going to use my calculator. So we need to have 4 times 9 times 7. So this is going to be minus 252. So if I go back to my calculator and do 36 minus 252, then under that radical we get a negative 216. Now the fact that it's a negative automatically should be telling you, okay, this needs to have i's in it. This is going to be imaginary. This is going to be a complex number. 216, you may not be that familiar with it, but it is divisible by some perfect squares. If you divide it by 36, it goes in 6 times. So in other words, square root of negative 216 is that square root of 36, that's square root of 6, and that's square root of negative 1. So 36 times 6 was 216. The square root of 36 turns into a 6 on the outside. The square root of 6 stays put, and this square root of negative 1 turns into your I. Now to keep this kind of clean looking, I usually like to put that I in between the 6 and the root 6. So I would usually write this as 6 plus or minus 6i square root of 6 all over 18. Then to finish off the problem, look at these outside numbers. We have a 6, and an 18. They're not reduced. We can divide all of those outside numbers by 6. So if I divide through by 6, 6 divided by 6 is 1. 6i root 6 divided by 6, this 6 goes away and we get I root 6. And 18 divided by 6 gives me 3. So my two solutions are 1 plus or minus I square root of 6 all over 3. Okay? In our last example here, we're going to do that quadratic formula again. So this is already set to 0. My A coefficient is 9, my B is negative 12, and my C is 4. So if we use quadratic formula, x equals minus b, so the opposite of b here would be positive 12, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So if we go and we try to simplify, 2 times 9 is 18. And now for our calculator, let me show you how I can enter all of this in at once. If we go to our calculator, you can just type in this entire expression at once. So parentheses, whoops, too many parentheses, parentheses negative 12 squared minus 4 times 9 times 4 gives me 0. So everything under this radical turns into a 0. And square root of 0 goes to 0. So in this particular example, we have no radical part at all. So this entire plus or minus goes away, and we just get one answer, 12/18, which isn't reduced. If we divide through by 6, this gives us 2/3. So the only answer that this one had was 2/3. Again, the fact that this answer is a nice rational fraction instead of having any radicals or any i's in your answer implies that the original quadratic you had was factorable. And indeed, if you did factor this, it turns into 3x minus 2 times 3x minus 2, or 3x minus 2 squared. And it's a square there because we only got one answer. Both factors were the same. So you could have factored this right off the bat. Okay? So here are our methods. When you look at these three solutions, notice that we had a couple different cases here. When the number under the radical was 0, we got one answer. When the number under the radical was negative, we got two answers, but they were complex. When the number under the radical was positive, but not a nice perfect square, we ended up with a square root in our answer, and these would be called irrational numbers. So sometimes what you'll hear referred to is this quantity, b squared minus 4ac. That's called your discriminant, and it determines how many solutions you have. So if this is a positive number, you're going to get two solutions. If it's a negative number, you're going to get two solutions that are complex. And if this discriminant is 0, then we only get one solution. Okay? So to summarize, how do we solve quadratic equations? Here's the three things you want to do. First of all, if the linear term is missing, which means there's no x term, isolate the quadratic term on one side and use that square root property. So this is that x squared equals to b gives you x equals plus or minus square root of b. So if there's no x term, you can take the square root right away and get your two solutions very quickly. If there is a linear term, then get a 0, get all your terms on one side and get a 0, and try to factor. If it factors, set each factor to 0 and you're done. If there is a linear term and it doesn't factor, then your two choices would be to complete the square and then use that square root property, or you could use the quadratic formula. Probably most instructors are going to expect you to be able to do it in both methods. They might ask you on a test or quiz to show one solution by completing the square and another problem using quadratic formula. So you'll want to know both methods. Okay? If it doesn't specify which way to do it, then you can use whichever one you are more comfortable with. Alright, that concludes our lecture on solving quadratic equations. Good luck.